I would like to introduce SHIWA, which is an FP7 project, started about a year ago. And the main goal of SHIWA is to provide technology for scientific user communities to integrate their systems, even if they are based on completely different workflows. This is a typical problem for the scientists, that they start with a kind of workflow system and then they are stuck with that workflow system and they cannot collaborate with other scientists who eventually selected another kind of workflow system. So this is very important to enable for these workflow systems to work together and to create a kind of technology by which can scientists integrate these workflow systems together. More than that, they can publish their workflow results and they can make available for other communities to build in their own workflow systems. And this all supported by SHIWA. We provide different kind of technologies. One important example to demonstrate the strengths of this technology is the usage of the LINGA challenge prototype, and this will be demonstrated by David.
Hi, I'm David Manset. I'm today showing a workflow application that we've developed in collaboration with the SHIWA project, representing the needs of the neuroscientific community. In our grid, we have been analyzing interoperability between three neuroscientific infrastructures to establish their interconnection. One is C-Brain in Canada, the other is LONI in the University of California in Los Angeles, and the other is NewGrid in Europe. With the collaboration in SHIWA, we have developed the technological bridges to communicate with these three infrastructures and to enable neuroscientists to establish data challenges spanning the three infrastructures and therefore taking advantage of the respective portfolios of scientific contents. LINGA stands for the Linked Neuroscientific Grand Challenge. The objective in LINGA is to demonstrate the interoperability that we've been promoting in Outgrid and further developing with the SHIWA platform, whereby we are making the three neuroscientific infrastructures working together towards a common goal, which is to evaluate the results of a biomarker for the Alzheimer's disease against three different data sets, continental data sets that are hosted by each of these three infrastructures, and then to repatriate the results, to statistically plot the result and to correlate the disease development with identified factors. To do so, we've developed, together with the SHIWA project, connectors to these different infrastructures, and we've designed a meta workflow, so to speak, that orchestrates the simultaneous work of the different infrastructures. In our today's demonstration, this is the SHIWA simulation platform, so-called SSP, where users can find definitions of their meta workflows. Here is the definition of the LINGA meta workflow that we have launched this morning, that's running now. And here you can see the list of sub-workflows that were spawned in the different connected infrastructures. This is one biomarker that has been spawned in C-Brain in Canada. It's currently running in Montreal. This is the equivalence free surfer that's been spawned in LONI in Los Angeles, and this is the third biomarker that's been spawned in NewGrid in Europe and more particularly in Italy. So all these three are running, and if we connect now to the authoring environment for biomarkers, we can retrieve the ongoing sessions and see the actual workflow running. This is here the LONI pipeline interface that is connected to the three scientific infrastructures, and from which we have retrieved the sessions, the workflows that have been spawned by the SHIWA scientific simulation platform. Here you can see the free surfer marker being run in Los Angeles. Here you can see the CVET pipeline being run in C-Brain in Montreal, and last but not least, here you can see the CVET pipeline being run in Europe in NewGrid. So what you see here is a demonstration of interoperability between three completely different distributed computing infrastructures, mixing technologies such as high-performance computing, clustering, and grid computing. And thanks to the SHIWA technology and concept, we have been able to design a so-called coarse-grained architecture that interconnects all these heterogeneous systems and allows users, neuroscientists, to design new scientific experiments.